Greetings, everybody. This video is going to give you just a quick review of trigonometry, and I'll get these notes posted. Um, well, first, you want to start off with you've got your Cartesian coordinate system, where in this figure here, and you can see you've got your x-axis and your y-axis. And notice we, in terms of the four quadrants, we start at the x-axis and the positive direction is counterclockwise, as indicated by this arrow. And so right here, you've got 0 degrees, and then you're going counterclockwise, and this this first quadrant, because we're dividing the coordinate system into four sections, that's Q1. Now right here, um, when you go counterclockwise, right here, you're at 90 degrees, which in radians is pi over 2. Then you keep going, we're going counterclockwise. Now we're in Q2. Then over here, we've got the angle is 180 degrees, which is pi. We're still going counterclockwise. Now we have Q3. And then down here, we have the angle is 270 degrees, which is 3 pi over 2. That's quadrant. That's going through quadrant 3, then quadrant 4. And then when we're back where we started from, we started off at 0. Well, now we've gone one complete circle, which is 360 degrees, which is 2 pi. Now, to keep things relatively simple, when we talk about an angle theta, we use what's called the reference angle. So no matter what quadrant you're in, notice here, just going, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, indicated by the arrow indicating the vector. Well, the reference angle is the angle that the vector makes relative to the x-axis. So in Q1, that's your reference angle. In Q2, theta is your reference angle. It's always the angle that the vector makes with respect to the x-axis. So that's theta in Q1, theta in Q2. Here's the angle theta in Q3, and then the angle theta in Q4. And this is why in that first lab, some of the percent errors in your angle was so high, because uh, of what quadrant your resultant vector happened to be in. But we can fix that, but we'll cross that bridge when we get to it. Well, now let's look how we obtain what are called the components of a vector. Well, let's just call the vector. Let's call it the vector A, and let's assume that that the vector A is in Q1. So you can see here's my coordinate system. The vector A is indicated by the purple vector. And remember, theta is what's known as the reference angle. It's the angle that the vector makes with respect to the x-axis. So the vector A is in Q1. That's my angle theta. Well, we simply use just a basic right triangle. We want to get what are called the x and y components of A. Well, we simply draw a right triangle with the vector A, the purple vector. That's your hypotenuse. And so here's the blue. That's the x component. Here's the green. That's the y component. And you can see that, let me zoom in a little bit. You can see that it is a this is a it's a right triangle, because clearly the angle between AX and AY, that's obviously a 90-degree angle. And so we have, remember, the trig function, you have sine theta, cosine theta, tan theta. Well, just using the basic trig, the sine of theta is the opposite over the hypotenuse. So the sine of theta is AY over A, opposite over hypotenuse, i.e., AY is just A sine theta, where A is the magnitude of the vector, and sine of theta, that's the sine of the angle theta. And likewise, the x component of AX is A cosine theta. Remember, cosine theta is adjacent, so cosine theta is AX over A, or AX is A cosine theta. So, but basically, with the reference angle, the y component is always going to be a sine theta. Using the reference angle, the x component will always be a cosine theta. Now, the sign of AY and AX, well, they could be positive or negative. It depends on what quadrant you're in. Okay? But again, right now, AX, the x component of the vector A, again, the vector A, think of it as really just the hypotenuse of that right triangle. So it's the purple vector A. The x component is a cosine theta. A cosine theta. The y component is a sine theta. Now the magnitude of A is given by the Pythagorean theorem. So A is the square root ax squared plus ay squared. Well, the angle is given by the arctan, also called the inverse tan. So theta is equal to the arctan of ay over ax. Now, we don't really worry about negatives when we're dealing with the angle theta because remember, we're dealing with what's called the reference angle. So all we want to know is what quadrant we're in. Well, remember, if you're in quadrant 1, ax and ay are both going to be positive. If you're in quadrant 2, ax is negative, ay is positive. Because you can see here, again, we're in quadrant 2. That's the vector A, that purple vector. You can see its x component is going to be negative. Its y component is going to be positive. So if you're in quadrant 2, ax is negative and ay is positive. Or conversely, if you know the sign of ax and ay, you know the quadrant. Okay, now here in Q3, ax and ay are both negative because see, the x component is going to the left in the negative x direction. The y component, you have to go down. So in Q3, ax and ay are negative. Now in Q4, ax is positive and ay is negative. So conversely, if you know the signs of the components, you automatically know what quadrant you're in. Hence, you automatically know how to draw the angle. So we don't worry about negative angles. We just want to know what quadrant we're in. Okay, well, let's look at an example. So here, I want to find the x and y components of this acceleration vector A, shown in this figure. Well, we know here the acceleration vector, it's in Q3. So I know its x component and its y component are both going to be negative. Because again, that's my reference angle. Notice it's not negative 30, it's just 30 degrees. So the acceleration vector makes an angle of 30 degrees in Q3. And again, step one, since the vector is in Q3, I know its x and y components will be negative. Okay, well, what are those components? Well, again, theta is 30 degrees, so what are the components? Well, ax is going to be minus a cosine theta. Again, why is it negative? Well, because look at the figure, look at the components. Ax is in the negative x direction. So ax is minus a cosine theta, so minus 6 meters per second squared times the cosine of 30, and you get minus 5.2 meters per second squared. I just get that. Now, what is AY? Well, I know, again, because the vector, in this case, the vector is an acceleration vector, because it's in Q3, again, I know its x component will be negative, and I know that its y component will be negative. Well, AY, because we're dealing with the reference angle, I know AY is going to be a sine theta, but again, I need the minus in front of it because I know that the y component is negative. So AY is minus a sine theta. So minus 6 meters per second squared times the sine of 30 gives you minus 3 meters per second squared. And you can see I've drawn the components. And you can see AX and AY are clearly both negative. But again, we're dealing with what's called the reference angle. The angle that the vector makes with respect, no matter what quadrant, it's the angle that the vector makes, oops, with respect to the x-axis. So in the example we just worked, the vector, the acceleration vector was in Q3. Now let's look at another one, which has become important when we get to projectile motion. Well, here's an example where somebody is running off a building horizontally, so their initial speed is entirely in the x direction. Well, gravity is going to pull the person down, so their speed is going to is no longer going to be horizontal. Their final speed will be indicated by that black vector. That v final, it has an x component and a y component. Well, notice in this picture here, right, vf, the final velocity of this person right before they hit that building, well, that vf is clearly in q4. So I know that the x component is going to be positive, but I know the y component is going to be negative. And so um, and then that when we calculate the angle, see the angle theta there was again what I call the reference angle. We don't worry about negatives when we talk about the angle. I want to know the quadrant. So we will say v final is excuse me, there. We say v final is 10.2 meters per second at 67.7 degrees in Q4. That tells me everything I need to know because where it's understood that when we talk about the angle, it's the reference angle. It is the angle that the vector makes with respect to the x-axis. And if the sign of VF and VY tell you the quadrant. And again, in this case, the y component, the green, that's negative. The x component, the blue, that's positive. So right away, that tells me that the velocity vector VF is in is in Q4, or conversely, because VF is in Q4, I know that the x component is positive and the y component is negative. And it turns out the x component turns out to be 3.86 meters per second. The y component, Vy final, is negative 9.39 meters per second. I know that has to be the case. Again, Vx, the x component has to be positive, and the y component has to be negative. How do I know that? Because look at the sketch. That final velocity vector Vf is clearly in Q4. It's clearly in Q4. And we know that in Q4, x component positive, y component negative. And conversely, if you know the signs of the components, you know what quadrant you're in. So you can go either way. And again, the x component is, in this case, ax is always a cosine theta. AY is always a sine theta because we're using the reference angle. The sign of AX and AY, that depends on the quadrant. That's why, again, in this example, here's my acceleration vector, the orange vector A. Well, I know that because it's in Q3, both the X and Y components, clearly drawn in this figure here, they are both negative. But again, long story short, what is the X component? A cosine theta. What is the y component? A sine theta. How do you know if they're positive or negative? Quadrant. Conversely, if you calculate the components, how do you know what quadrant you're in? Well, the signs. And again, again, quadrant 1, x and y components positive. Quadrant 2, x component negative, y component positive. Quadrant 3, both components, x and y components negative. Quadrant 4, x component positive, y component negative. What is the angle theta? It is the angle that the vector makes with respect to the x-axis. And that's it. Well, I'm going to get this posted.